Hello everyone. In the today's lecture, we will be discussing the second module in the digital communication subject, which is a signaling over AWGN channel. And to understand this module, you need to have the basic knowledge related to two subjects, information theory coding as well as the vector system. And since you are already familiar with these topics, it is not so difficult to understand the topics belongs to this particular model. The title is the signaling over AWGN channel. It means the transmission of digitally encoded signal through the analog channel, which is mainly the AWGN channel. So to understand what is the signaling or AWGN channel, that is the transmission of signal through the AWGN analog channel, let us consider an example where there is a remote connection is established between the two digital computers. In the figure you can observe there are two digital computers. The first digital computer acts as the information source and the second digital computer acts as the information recipient, which is nothing but your receiver. So information source which emits the digital data or digital output consisting of the sequence of binary zeros and ones, and this sequence of binary zeros and ones are digitally encoded into sequences, namely S1 of t and S2 of t, where S1 of t corresponds to the digitally encoded signal for binary symbol 0 and S1 of t corresponds to the digitally encoded signal for symbol 1. Once these digitally encoded signals S1 of t and S2 of t, they have to be transmitted through the analog channel, and here the channel which we have considered is AWGN channel. So why the name given to this channel is AWGN channel? So whenever you transmit any signal through the analog channel, and each analog channel is characterized by its own noise, and this noise is going to be added to the transmitting signal. So this noise has the additive in nature. That's why the first letter additive means the noise has additive nature, and white means AWGN, additive white. Why the name given to noise is white noise? Because if you take the example of different colors, and each colors have different frequencies and intensity, and when you combine all different colors with different intensity as well as frequency, you will get a white noise. You will get a not white noise, white color. And irrespective of the frequencies of different color, the intensity of white light will be a uniform for both positive frequencies as well as negative frequency. Similarly, the white noise has the constant uniform power spectral density irrespective of positive frequency as well as negative frequency. That's why this noise is termed as white noise. And the Gaussian means this is the name of the person who has studied this noise. That's why the name given to this noise is AWGN noise, and the channel which is characterized by this noise is called as AWGN noise. When the transmitted signal Si of t is combined with additive white Gaussian noise through the transmission, during transmission, the resultant received signal is denoted by X of t, which is the sum of transmitted signal Si of t and additive white Gaussian noise W of t. Once the received signal is taken, it has to be given to the receiver, and the receiver has a task of the two things. It has to observe the received signal X of t, and based on the received signal X of t, it has to make an estimate of the transmitted signal Si of t. Means it has to verify whether the received signal is an estimate of transmitted signal or not. That means, is the received signal X of t is similar to the transmitted signal or not? And however, since the presence of the noise, channel noise, we cannot expect the same transmitted signal at the receiver side. The received signal is obviously different from the transmitted signal, and that gives the occasional errors. And therefore, the requirement is to design a optimum receiver so as to minimize this average probability of symbol error. And this average probability of symbol error is denoted by P, which is given by the expression pi 1 P of m cap. M cap means it is a estimated message symbol. M cap is equal to 0 when 1 is sent. That is, the received signal will be 0 when 1 is sent, and pi 2 of P of m cap is equal to 1 when 0 is sent. You can observe in this equation the estimated symbol will be 0 when 1 is sent at the transmitter side. So means the transmitted signal is not available at the receiver side, since it gives the probability of error. Similarly, when you send 1 at the receiver side, the received signal will be 0 or vice versa, where pi 1 and pi 2 are the prior probabilities, and m cap is nothing but the estimate of the transmitted symbol 1 or 0 by the source emitter, and P of m cap is equal to 0 when 1 is sent, and P of m cap is equal to 1 when 0 is sent. They are called as conditional probabilities. And in digital communication system, the main objective is to make the digital communication system as reliable as possible by minimizing the average probability of symbol error. Then how to achieve this objective? So here we have to understand the two basic principles or issues. What are those two basic issues? The first one is how to design the optimized receiver to give the minimum average probability of symbol error so that we can achieve the maximum reliability for the given digital communication system. And the second issue we have to understand is how to choose the different set of signals, that is encoded signals S1 of t, S2 of t, so on up to Sm of t, for representing the symbols M1, M2, so on up to Mn, since the choice has effect on Pe. So the probability of error is mainly depending upon how you choose the set of signals. And the answer to this fundamental question, which is related to the above two issues, is found in the geometrical representation of signals, right? And this geometrical representation of signal will be discussed in the next lecture.